Hello, Geometry B students, and welcome to our first recording for testing week. So sad we don't get to meet live, but hopefully this is good enough. So here we are going to have our class starter. With the information given below, determine how triangle TUD can be shown to be similar to triangle SUY. We are given that TU is equal to 15 centimeters, DU is equal to 18 centimeters, ST is equal to 10 centimeters, and YD is equal to 12 centimeters. The correct answer is C. The triangles are similar by side angle side. First of all, we know that we have two proportional sides because of the segments that were given to us plugged into this proportion over here. And since we got out a true statement, that means that the sides are proportional. So we have two proportional sides. Now the angle is the angle that's congruent that they share, angle U. So they are similar by side angle side. Alright, so that was our class starter. Next up will be announcements. Then we'll go over our previous class exit ticket. Then we'll go over our goals and objectives. Then we're going to talk about two kinds of special triangles. Then we're going to look at laws of sines and cosines. Okay, so here's our announcements. Obviously, we have no live sessions this week. So you should be watching the recording for our lessons. What's due this week is, first of all, you've got the EOC Constructed Response Practice 1. So this is just practice in the OHS for you to look at one of the constructed response questions that the state released. It is for a grade for completion and effort. Okay, so don't freak out, but do try your best. And we will talk about it together as a class. This week's quiz is WFA 12. It's in 3 parts. That is located in your content, so make sure you're taking those. This week's lessons is just 5.08, which is just the Unit 5 review. That's all that is. And then when you have all your lessons complete, you want to complete your practice EOC tests in Eagle. That's this week's main focus. Our next gating date is April 13th. That's on a Thursday. And here are the assignments that are closing at that gating date. All right, here is the information from our last exit ticket. We made a C overall for those that answered it, so pretty good job. And so let's review these 3 questions that we failed. So the first one was, to find the measure of the angle given that the sine of that angle is 0.2756. So in order to do that, we'll have to use the inverse sine. So the inverse sine cancels out the regular sine, and we are left that the measure of angle C is approximately 16 degrees to the nearest whole degree. So this is what you type in your calculator. If you have a less capable calculator, you kind of have to type it in reverse. So keep that in mind. Alright, if we want to find the angle measure for y, that means that we will need to take the inverse tangent of each side. The inverse tangent of each side. These cancel, so we're left with y is equal to the inverse tangent of 0.6494. When you put that in your calculator, you get 33 degrees approximately for y to the nearest whole degree. But I don't think I saw anybody make any rounding errors. All right, here's the last one. A boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? So let's draw a triangle, obviously a right triangle, since that's what our whole unit is about, to depict this scenario. Okay, so we have the boy flying a kite on a string. The rest of the triangle comes from the distance from the kite directly straight down to the ground, and then the third side is the ground. So this is our right triangle here. Okay, so I'm going to label those pieces. So that means that the boy is down here at this point. It means that the kite is up here at this point, and that the kite string is what we have in orange, which is 300 feet. Okay, so then it says, assuming that the angle the kite makes with the ground, that's going to be this one right here, because the ground, we said, was this bottom leg. This is the ground. So the angle that the kite makes with the ground is 38 degrees. We want to know how high above the ground is the kite. So our unknown here is the height that the kite is from the ground. So that's going to be the leg that's vertical, where I put the X. So now I have to label the sides of my triangle based on the reference angle that I'll be using. So my reference angle is 38 degrees, so that makes the string the hypotenuse, that makes the height the opposite, and that makes the ground the adjacent. And so the information that I have is the hypotenuse at 300 feet. And the information that I need is the opposite, because that's the height. So I'm not going to be worried about the adjacent at all. So then if I think about my three trig functions, sine, cosine, and tangent, SOHCAHTOA, and the one that uses the hypotenuse and the opposite, the O and the H, is going to be sine.
So the sine of an angle is equal to the opposite over the hypotenuse. Okay, so the sine of 38 is equal to x over 300. Multiply by 300 on each side. And we are left with 185 feet for x.
An approximation. All right, remember our overall goal is to score good or excellent on the EOC. So remember some of your ideas that you said for how to do that, study and look back at the lesson. That's a good one. And here's our standard that we're going to be addressing today. Understand that by similarity, side ratios in right triangles, including special right triangles, 30, 60, 90, and 45, 45, 90, are properties of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. And here are the three objectives that we will be working on. The first one will be to use the relationships in 45, 45, 90 triangles to solve problems. Then use the relationships in 30, 60, 90 triangles to solve problems. And then use the law of sines and the law of cosines to find missing measures in triangles. Before we start working on these objectives, let's work on simplifying square roots. So remember that a square root is looking for the number that was squared to make it. So for example, 2 squared is equal to 4. Thus, the square root of 4 is equal to 2. Let me give you one more example. 5 squared is equal to 25. Thus, the square root of 25 is equal to 5. It's also helpful to know several of the first few perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16,
5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144.
And I'm out of room. So keep those in mind. To simplify a square root, we want to take everything out from underneath the radical that we can. Since 28 is not found in the list, it lands in between 25 and 36. So we can see 28 is not a perfect square. We want to remove any perfect square factors that go into 28. So we know that we are going to be limited to looking at all of the values that are smaller than 28. So do any of those perfect squares, besides 1, because 1 goes into everything but won't change anything. So do any of those perfect squares go into 28? If you noticed, 4 does. So let me rewrite this. So this is the 4 on the outside. But I'm going to rewrite 28 as a product of 4 and 7. I can also, using rules about radicals, I can rewrite this radical and split up the 4 and the 7. Okay? So the square root of 4 times the square root of 7 is the same thing as the square root of 4 times 7. All right, I'm going to keep bringing everything down. Now I can simplify. The square root of 4 is actually just 2. This is all multiplication in between these all the way down. But here, 7 doesn't have a square root that is nice, so we leave it inside the radical. Now I can simplify 4 times 2, and I'll get 8 square root of 7. Okay, let's try another one. We have 3 times the square root of 80. So we want to look for any perfect squares over to the left that go into 80. So we know it has to be from the list of perfect squares that are smaller than 80. So you might have noticed more than one answer. 4 does go into 80, but so does 16. We like to pick the largest one if we noticed it. If we didn't notice it, then we would just have to repeat the process again later on. Alright, so we've got the 3 that's still on the outside. I'm going to rewrite 80 as a product of 16 and 5 because 16 times 5 is 80. So I'm going to keep the 3 on the outside. I'm going to go ahead and take the square root of 16, which is 4. So it gets to come outside of the radical. The 5, however, has to stay inside the radical. Then I'm going to simplify. 3 times 4 is 12 times the square root of 5. You try. Simplify 5 times the square root of 360. And the correct answer is C, 30 times the square root of 10. All right, now let's just review about multiplying square roots. This is the rule right here. Outside times outside and inside times inside. So what I mean by that, the numbers outside in this example are 6 and 3. These are called coefficients. So only the 6 and the 3 can be multiplied together. Okay, so 3 times 6, 18. Then the inside times inside, these are the numbers that are inside the radical. That is the 10 and the 2. These are called radicands. So you can only multiply coefficients together and you can only multiply radicands together. So in this case, 10 times 2 is going to be 20. Are we done? No, because we can simplify further. There is a perfect square that goes into 20. What is it? So 4 goes into 20. 4 times 5. So when I take out the square root of 4, I get 2. The 5 stays in the radical. And then 2 times 18 is 36. Now let's review dividing square roots. you can multiply the numerator and the denominator by the square root in the denominator, then simplify. So dividing square roots basically has the same concept as multiplying. The coefficients, or the numbers outside, cannot intermingle with the radicands, or the numbers inside. But there is one more rule, and that is we cannot leave this radical in the denominator. We have to go through the process described here, which is called rationalizing the denominator. And that means getting rid of the radical in the denominator. It's kind of like how we usually like to write our improper fractions as mixed numbers. It's that same process. So to get the radical out of the denominator, we want to create an equivalent fraction. In order to create equivalent fractions, we multiply by a fraction of 1. In this case, we're going to use what is in the denominator. So we are going to multiply by the fraction of 1, represented by the square root of 2 over the square root of 2, because it doesn't change the value. So when you're multiplying fractions, you just multiply the numerator straight across. That's going to be 6 root 2. Remember, the 6 and the 2 cannot intermingle. And then in the denominator, we have the square root of 2 times the square root of 2. Because they're both radicands, they can intermingle, and we're left with the square root of 4. All right, now I've got some simplifying I can do. The square root of 4 is just 2. My numerator is still 6 square root 2. I've got even more simplifying. Now that the 6 and this 2 are both outside of the radicals, we can go ahead and reduce that fraction. So 6 divided by 2 is just 3. And my root 2 still hanging on. 3 root 2. All right, let's get started on our first objective. Use the relationships in 45, 45, 90 triangles to solve problems. This is important, guys. I don't know if you saw earlier, but it's a green standard, and this band is worth 40% of your test. All right, so a triangle from a square. The length of the hypotenuse as a simplified radical. So this is what we're working on now. These are essentially isosceles right triangles. So that means that we have, since it came from a square, we know this is a 90-degree angle. And if both of those side lengths are the same, that means that these angles are the same. So if these two angles are congruent, what are their measures? They're both 45 degrees because all the angles in a triangle have to add to 180. So if this guy already takes up 90 and the other two have to be congruent, that must mean that they are both 45 because 90 is what remains divided by 2 is 45. Now if we wanted to find the length of this diagonal of the square, or the length of the hypotenuse as it could also be called, then we would just need to do the Pythagorean theorem formula here. So we know that the formula is a squared plus b squared is equal to c squared. If we plug the legs in, we will find that we get 9 plus 9, which is 18. And then if we want to take the square root of each side, we know that we can simplify that. We know that 18 has 2 of the perfect square 9 inside. So if we take the square root of the 9 back out, then we are going to get 3 root 2 as our simplified version of the hypotenuse, 3 root 2. So, do you think that there is a connection between the 3 in our answer and the 3 for the length of the leg? Quite possibly. Let's move along to find out. So here you go. This is the shortcut for all 45, 45, 90 triangles. So you can always use the Pythagorean theorem formula, but they also would like for you to know the relationship that is formed in this special 45, 45, 90. In that, you will always have, you will always have a times the square root of 2 for that hypotenuse. So whatever your two legs are, they're going to be the same value for a 45, 45, 90 because it's an isosceles. And then your length for your hypotenuse is always going to be that length of the leg times the square root of 2 every time. So all the legs are equal, and the hypotenuse is the leg times the square root of 2. So let's try some of those. They're so much faster than having to use the Pythagorean theorem. So let's find x and y and give answers as simplified radicals. Yay! Okay, on the left, we know that this is a 45, 45, 90 because this is 90, this is 45. So all that's left is 45. Don't have to do any calculations. That's just a given. All right, so to find the value of x, well, the legs are congruent because it's an isosceles triangle, so x is just 10. Wow, yes. All right, so then now let's try the hypotenuse. Remember that the hypotenuse is going to be the leg times the square root of 2. If the leg is 10, and I've plugged it in, that's it. That's all there is to it. Oh my, oh my, oh my, oh my. All right, let's try this one over to the right. This is a 45, 45, 90 because we got the 90 marked and we have congruent sides marked. That means these two have to be 45. Every isosceles, right, triangle has 45 degrees for the acutes. Every time. Okay, so this time we're given the hypotenuse and not the legs. This time the hypotenuse is 10. So remember that. You can see it up at the top. Leg times the square root of 2 is going to give you your hypotenuse. So if we plug in our hypotenuse, which is 10, what are we going to do to find the leg? Well, we're going to divide by the square root of 2 on each side. So now this is where that review came in handy. So we can't leave that square root of 2 in the denominator. Boo, boo. So we're going to multiply by a fraction of 1 using the denominator. It's a fraction of 1 because these are the same. All right, so 10 times the square root of 2 is 10 times the square root of 2. The square root of 2 times the square root of 2, remember, is the square root of 4, which is just 2. I can simplify that some more. Boom, boom, we can reduce. So the legs are equal to 5 root 2. What's the value of x? X is 5 root 2. What's the value of y? Oh, y is 5 root 2. Because the legs are congruent. Radicals in the real world. So let's think about that. First, let's use this diagram to find the distance from home plate to second base. From home plate to second base. How can we do that? I don't see a triangle, Miss Wooten. I just see a diamond. Okay, well, yes, but it's kind of like a square, right? And the distance from home plate up to the second base, basically cut this into two congruent right triangles, OMG. And since they're all 90, it's a square, that means that everything is 90. That means these are congruent. That means that these are both 45-degree angles. Thus, we have a 45, 45, 90. Yeah, yeah, yeah. All right, so that means that this is going to be x, this is x, and this is x root 2. All right, let's go, let's go. So we need to find the hypotenuse of this triangle. Okay, we know that x is equal to 90. Thus, the hypotenuse is 90 times the square root of 2. All right, case closed, we're done. Are we? So let's think about this. Are you really going to tell someone that's building a baseball field, I would like for the home plate to be 90 root 2 feet away from second base? No, you're not going to do that. So anytime you see a real world problem, you can almost get excited that you don't have to worry about simplifying any radicals. What you are going to have to do is plug this into your calculator. We need to tell our calculator to do 90 times the square root of 2, which is approximately 127.3 feet. That is the approximate distance. We don't want radicals in the real world. Sorry. All right, you try this one. Find x in simplified radical form. The correct answer is D, 9 times the square root of 2. All right, that's all for our first objective. Go ahead and tell me how you feel about that one. If you didn't feel too great, check out the School Yourself Remediation video. They are awesome. Next objective. Now we're going to be moving on to 30, 60, 90 triangles. So where do you think the 30, 60, 90 means? This is also important. Importante. All right, a smaller triangle from an equilateral triangle is what makes our 30, 60, 90s. The length of the legs as simplified radicals. So if we started with an equilateral, so we know that we have 8 there. And so then what does that mean for this leg? Well, this leg is going to be 4. It's half of 8, right? All right, now if we want to find the other leg, we can use the formula for the Pythagorean theorem. So my first leg is 4, second leg is unknown, and my hypotenuse is 8.
We do some simplifying here. And when we simplify that radical, it has a perfect square of 16 that goes into it, and the square root of 16 is 4.
So, do you think that there is a connection between this 4 and this 4? Let's see. Here is the work done for 3 other 30, 60, 90 triangles. So if the hypotenuse was 6, half of that was 3, and then the height of that triangle was 3 root 3. In this case, the hypotenuse was 4, so that means x is 2, and then the y was 2 root 3. In the third triangle, when the hypotenuse was 10, half of that was 5, the third side was 5 root 3. So to sum all of that up, here are the rules. In words, your short leg times 2 is your hypotenuse, or you can think of it as, remember you can think half of your hypotenuse also is your short leg. And then your short leg times the square root of 3 is going to give you your long leg. So this is what it looks like in the diagram. So it all starts with S for the short leg. Okay, so your hypotenuse is 2 times the short leg, and your long leg is the square root of 3 times the short leg. So let's try some of those. And again, remember, these are just patterns that happen every time you have a 30, 60, 90 triangle. This first triangle on the left I know is 30, 60, 90 because it tells me the 90 and it tells me the 30. So the only thing that's left is 60 degrees. 4 is given to us. This is our short leg. I know that because x has to be the hypotenuse and y is across from the unmarked 60 degree angle. 4 is across from the 30-degree angle. That makes it the shortest side. So if we remember our rules, okay, to find our hypotenuse, which in this diagram is x, we are going to double our short side. So 2 times 4 is what is going to give us our hypotenuse, and that will be 8. So x is equal to 8. Now to get the long leg, we must do the short leg times the square root of 3. And that is going to give us our long leg. Okay, so the short leg again was 4 times the square root of 3 is our long leg, which is y. Okay, let's try this one on the right. So we have a bigger triangle here, but we can see that this line drawn is a perpendicular bisector of this other base of the triangle. Okay, we know that we have that is 15. This is also going to be 90 here as well. So when we find out the value of y, and then we can find out the value of this leg, it's going to be the same as the value of the x that I need to know since they're marked congruent. So we know that in this top triangle that this is our short leg because it's across from the 30-degree angle. Okay, this is our long leg, and then y is our hypotenuse because it's across from the 90-degree angle. So let's go ahead and find the short leg first. Okay, so the short leg times the square root of 3 is going to be equal to the long leg, which is 15. If I divide by the square root of 3, then the short leg is equal to 15 over the square root of 3. I'm going to multiply by a fraction of 1 using the denominator. So I've got 15 times the square root of 3 over 3. The 15 and the 3 reduce. 15 divided by 3 is 5 root 3. That is your short leg of the top triangle, which is congruent to the value of x. This is also x. Now I can use this to find the hypotenuse. Remember that 2 times the short leg is what's going to give us our y value, the hypotenuse. So 2 times 5 root 3 is equal to y. So our value for y is 10 root 3. All right, back to some more radicals in the real world. A point on the edge of a symmetrical canyon is 4,500 feet above a river that cuts through the canyon floor. The angle of depression from each side of the canyon to the canyon floor is 60 degrees. Find the distance across the canyon. Okay, so you can see in the diagram that is drawn out for you that we have got the height and the angle of depression, and that's going to give us a right triangle that gets us halfway across the canyon. We know this is a 30, 60, 90 triangle because it's 45 degrees and it's a 60 degree angle that was given to us here. So that means the other one is going to be 30. So that means that this over here is our short leg. That means that the height, 4,500, is going to be the short leg times the square root of 3. And that means that the slanted part of the canyon is our hypotenuse, and that's going to be 2 times the short leg. So in this scenario, I'm not actually worried about the hypotenuse. I want to find the distance across the canyon. That's the short leg is what's going to help me with that. And then the other one that I have is the 4,500 feet. That's going to be the short leg times the square root of 3. So I set up my little formula. The short leg times the square root of 3 is 4,500. I'm going to divide by the square root of 3 on each side. So the short leg is equal to, now I need to get rid of the radical in the denominator. So I've got 4,500 times the square root of 3 over 3. But then I can simplify this to 15,000 times the square root of 3. Now that's the length of my short leg, but that's only half the distance across. So I need to double it to find the rest of the distance across. So it will be 30,000 times the square root of 3. Remember, the 2 cannot interact with the 3 because the 2 is a coefficient and the 3 is a radicand. Now, the canyon is 3,000 square root of 3 feet across. Psh, no, nobody likes that as an answer when we're talking about the real world. So we have to actually plug it into our calculator to get the estimation of how many feet it is across, and that is 5,196.2 if we were going to round to the nearest tenth. Always round to whatever the directions tell you to. All right, you try. Find x and y in simplified radical form. And the correct answer is B. All right, so we are finished with our second objective. Let me know. How successful do you feel about using the relationships in 30, 60, 90 triangles to solve problems? If you don't feel so great, check out the links to school yourself. They're very helpful. Let's move on to our next objective, using the law of sines and the law of cosines to find missing measures in triangles. Here is the law of sines. The law of sines states that all of the sines of each of the angles are proportional to the lengths of the opposite sides. Okay, so we can see that angle A is here. Well, side A is the side that is opposite of angle A. So they can all be set up in a proportion. So if we want to use the law of sines to help us find the length of side B, well, we know that if side B is what we're trying to find, that we will be using the sine of angle B, and then we can set that up in a proportion with the information that we have. We can see that we have the sine of angle A, and we have the measure of side A that is across from angle A. So when we plug all this information in, the sine of 80 over B is equal to the sine of 40 over 16. So I'm going to cross multiply and solve. So that means I've got 16 times the sine of 80 is equal to B times the sine of 40. Divide by the sine of 40 on each side. And now I'm going to have to plug this step into my calculator. So I've got 16 times the sine of 80 divided by the sine of 40. And I get 24.5 for the length of B. Make sure your calculator is in degrees and not radians. Okay, let's use the law of sines to help us find the measure of an angle. So in this case, I have 75 degrees and the opposite side of 25. I want to find angle S, and I am given the opposite side of 23. So my proportion will look like this. The sine of my unknown angle S over the length of the opposite side is equal to the sine of my known angle R, which is 75 degrees, over the length of the opposite side, which is 25. Cross multiply, and now solve. So now we have found the value for the sine of s, but we need to find the value of s. So in order to find that, we take the inverse sine of each side. So the measure of angle s is approximately 63 degrees to the nearest degree. Here is the law of cosines. It's a little bit more complicated. Okay, it looks a little bit like the Pythagorean theorem, but there's quite a bit more going on. So angle is the same concept where we have angle A and across from that is side A. Okay, so we can take the side in question squared is going to be equal to the squares of the other two sides added together minus 2 times the other two sides times the cosine of that angle in question. Okay, so the angle and the side pair that you're using go on the outsides, while the sides that you are not using are going to go on the inside. Crazy, crazy, I know. Let's try one. We are trying to find the measure of angle C. If you notice, we can't use the law of sines because I don't have the measure of angle B or the measure of angle A. So it's not going to help us there. So that's why we're going to have to use the law of cosines. So we're going to use the one that we have to put the angle in question and the side in question on the outsides of the formula. So it's going to be c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of angle C. Woo! So plug in what we know. We don't know C. A is 8 because it's across from angle A. B is 14.5 because it's across from angle B. Minus 2 times 8 times 14.5 times the cosine of angle C, which is 74. If you have a scientific calculator, you can type all of that in at one time, exactly like you see it, and your calculator will take care of the order of operations. Otherwise, you need to be careful to do the breakdown of the order of operations, taking care of your exponents first, then your multiplication, then the addition and subtraction from left to right. When I take care of all of the order of operations, I get that c squared is equal to 210.3. And then when I take the square root of each side, I'm going to get that c is approximately 14.5. Okay, let's try one where we want to find the angle. Again, we could not use the law of sines in this scenario since we have 3 sides and no angles given to us. But we can still find the measure of angle B. So since B is what I want to find, I'm going to use the law that starts with side B. So I'm going to put b squared is equal to, then I'm going to use the other two sides, a squared plus c squared, minus 2 times a times c, times the cosine of angle B, the one I'm trying to find. Plug in the information we know. Side B is 38 because it's across from angle B. Side A is 46. Side C is 15. Side A again is 46. Side C again is 15 times the cosine of B that I'm trying to find. So in this case, we're going to have to do them, simplify it in a few different steps. So
38 squared is 1,444. 46 squared is 2,116. 15 squared is 225.
So now I'm going to combine like terms right here.
2,116 plus 225 is going to give me 2,341.
I'm going to subtract 2,341 from each side.
Then I get negative 897.
I'm going to divide by negative 1,380. And I will get a positive 0.65 for the cosine of B. But remember, to find the angle measure, now I need to take the inverse cosine. And that's going to leave me with the measure of B, which is approximately 49.5 degrees. You try. What is side length B? Round to the nearest whole inch. First, you need to figure out, will you be using the law of sines or the law of cosines on this problem? You will be using the law of sines because you have two angle measures and one side length while you are trying to find one side length. And the correct answer is B. I forgot to mention that it is helpful to save the very last step before actually plugging in the sine of an angle into your calculator. You try this one. What is B? And round your answer to the nearest meter. Before you begin, decide, are you going to be using the law of sines or the law of cosines? You will be using the law of cosines because here you are given two sides and one angle, and you're asked to find a third side. And the correct answer is D, 15 meters. That's all for our last objective today. So tell me how you felt about this one. Check out the links to school yourself if you chose C, D, or E. All right, so for your exit ticket, there is not an official exit ticket today, but it is, you do need to look through how well you did on this Ed Puzzle lesson today. If you scored less than 67%, then you need to review the material and extra resources from these lessons. Consider watching this video again. Attend live help, office hours, virtual math lab, or blended site tutoring for more help next week. If you passed with a C or a D, download the problem sets and answer keys from lessons 5.05 through 5.07. Work through some and check your answers. Bring any confusing problems to live help next week, or email Ms. Rutan right now with any questions that you might come across. So like not really now, but when you have questions on the problem sets. If you made an A or a B, congrats! You've mastered the material. Catch up on missing assignments or work ahead. And don't forget to go to Eagle and work on that practice EOC test. Have a great week. Also, you will want to complete today's DFA. You thought I'd forget, didn't you? You thought that I would. In order to complete today's DFA, you will find it in your course releases. So you will need a secret word as usual. So stay tuned for the secret word.